This talk is going to be about detecting illicit sales of opioids using AI. And this was primarily the work that I did when, towards the end of my doctoral studies and during my postdoc time at UCSD. I was a postdoc briefly at UCSD right after I graduated. So the way that this work really came about was that my thesis focused on building machine learning-based models to analyze social media data. And towards the end of my thesis, I really wanted to see, what kind of impact am I really making in society? I'm building all these models, and most of the papers I wrote would end up, comparing the model that I built to, a bunch of baselines. And I would compare NDCG scores, AOC scores, MAP scores, and what have you. And I would say that my model did better than all these other baselines. But I still didn't feel like I was having impact, and my thesis was having an impact. And that's when I started, reaching out to people outside of my realm. And this is work that's done in collaboration with researchers at University of San Diego Health System and the medical school at UCSD. So we'll get started. So I want to start off by telling the story. And this is how this problem was actually introduced to me as well. Ryan Haight, when he was a teenager in 2001, he died of drug overdose, and that was from purchasing Vicodin from an online pharmacy, and from an illicit online pharmacy. And the way that these illicit online pharmacies work is, I know this because I've tried buying drugs, it's literally a marketplace, which arguably it looks very shady in terms of the kind of website design and everything, but they accept credit cards, and you can place orders for drugs like Vicodin and Percocet and a few other examples that I will show. You can place orders for those drugs and pay for them online and have them delivered. And this is extremely dangerous given the kind of effect that these drugs can have on the human body. So after the death, and I was told that his mom was very passionate about making sure that the same thing does not happen to other teenagers and other kids as well. And several years of hard work, a federal law called the Ryan Haight Online Pharmacy Consumer Protection Act was passed in 2008, and that was specifically designed to address the effect that internet has in the space of illicitly selling drugs online. So what that eventually ended up creating is that there were lots of policies and guidelines that were put in place to make sure that there aren't any illicit online pharmacies, giving direct access to customers to dangerous drugs. But the piece that was missing there was that the role that internet played, and that's about the time when social media was also emerging in a really big way. The role that internet played and the role that social media played in terms of marketing this drug and actually letting their presence known to a very vulnerable demographics. The solutions, such as putting guidelines as a way of regulation, just did not scale. And what I also learned was that there are about 110,000 websites, out of which websites that sell drugs, out of which 96% are not in compliance. And not in compliance meaning that they don't require valid prescriptions, or sometimes a bunch of questions and questionnaires in terms of what kind of symptoms do you experience pain, etc., was enough to give access to these dangerous drugs. And because the solution that was put in place was clearly not scaling along with the rise of internet and social media, we needed something that needed the power of AI. We needed something that could automatically detect certain type of content as soon as it emerged, and we needed to exterminate them as soon as possible. And before the work that I've done, there's tons of research that actually shows clear association between social media and illicit sales of drugs. Not only illicit sales of drugs, but there's also research that connects social media to behaviors of drug abuse as well. And I think that it is at this intersection that most of my work lies in, and this is kind of what got me interested in saying that. So my work in developing models to analyze social media data is something, applied to this regime can really make an impact. So let's see, the rest of the talk. Oops. So the way that I thought about this problem, the one challenge that I faced when I was working on this problem was that this is not a case where some clean ground truth data was handed down to me and I had to build a model to achieve a certain level of accuracy. Right? We knew that a certain association existed between social media data and drug abuse. We knew that there are a bunch of online pharmacies out there selling these drugs. And we also knew that they were out there reaching out to people on social media. So these were all qualitative studies that had been done before. But when it actually comes to building AI-powered solutions, I needed something that really scaled. So this is kind of the overall pipeline approach that worked out in this research study. So Twitter is a very volatile space, and more than 350,000 messages get published every minute. And in order to analyze this content is very volatile, and because anybody can publish anything they want. In terms of content, it's highly variable. There's a lot of noise, and there is huge volatility and ununiformity across the platform, right? So what we needed was that, So we needed a model that is able to identify what kind of data actually exists on Twitter. How do I collect this data? How do I go about creating the ground truth? And how do I eventually develop a model that is able to classify, sort of the good actors from the bad actors? So the way that my pipeline began was so I said, okay, so Twitter gives this public API that allows you to collect data in an almost live fashion. And the Twitter streaming API allows one to give certain keywords using which the tweets can be, the tweets can be segregated. So the Twitter streaming API, I used the Twitter public streaming API, and certain drug-based keywords that I used were things like codeine, fentanyl, hydrocodone, oxycodone, OxyContin, Percocet, and Vicodin. So before narrowing down on these set of keywords, one of the things that we considered were, well, if someone is actually trying to abuse drugs, it's very highly likely that they use the street names of those drugs in order to be able to get access to those. But the problem is that those street names are often conflated with regular names, and that actually added a lot of noise to the data. Something like Coke. Coke could mean several things on a social platform like this. So that was one of the reasons why we chose to use scientific names. And what we did was we collected data for these set of keywords over a period of 5 or 6 months using the Twitter Streaming API. And we had a reasonable data set size of 1 million tweets. And so I have this set of 1 million tweets, but I really have to go about figuring out what kind of tweets are actually selling these drugs online. What are the characteristics of the tweets that actually are related to illicit online pharmacies, right? So I know earlier during the day, someone mentioned, I think it was the Slack talk. When they mentioned topic model, I was really excited because topic model is almost something that's become obsolete over the past few years, given the emergence of deep learning and NLP. But the model that worked really well in this setting was a topic model. This paper was published in 2013 in KDD, I believe. It's called the bi-term topic model. And what happened was that once these set of tweets were collected, applying a simple topic model basically gave a good overview of the types of tweets that were published on these social media websites. The types of tweets that contained these keywords that published any type of content on these social media websites, right? And beyond that, what one could do was we could take a look at these topics, see what those topics were, and later delve into analyzing what each topic was really about. So here are some examples of topics that we got as outputs, right? So here. Okay. So for coding, I've shown a list of 3 topics here. So there's the first topic, there's a second topic, there's a third topic that says best free pills online buy. So these are tweets. So these are the top few words from each topic that I'm displaying. So what this tells me is that there is a topic in the coding data set, as in the data set that contains all tweets about, a subset of tweets that contains the word codeine. And the top words in the topic are best free pills online and buy. Now that is a very strong signal that tells me that all the tweets under this topic are probably related to illicit online pharmacies, right? And the interesting thing was that this result was highly reproducible across all drug classes. So we see something similar for OxyContin, we see something similar for Vicodin, oxycodone, Percocet, and hydrocodone. So this was consistent across all the drug categories. There was always at least one topic that had words that were very highly suspicious, giving signal that these tweets are probably selling drugs online in an illicit fashion. And this was also consistent across time. So this is a result from a data set that was collected in 2016. But no matter at what period the data collection was performed, I think this was between June to November, I believe. But if we repeated the same experiment from January in another data set from January to March or April, very similar results. So these results were consistent across time as well. So you can see where the next step would be going. So what we did after this was that we basically isolated these tweets under this topic, and there was a little bit of manual coding involved. But that manual coding was much easier and at a much smaller scale than all the 1 million tweets that I would have had to code in order to create my training data set, right? And these, so the second step involves looking at all the tweets that were highly correlated to this topic, and then actually, manually labeling if they were actually related to illicit online pharmacies or not. And that had a very high rate of precision. It was close to 90%. So once we isolated those tweets, the nice thing about Twitter is that it's a platform that kind of lends itself to be able to featureized in a really nice way. So now I basically have my training data set. I have a set of tweets that I think are related to illicit online pharmacies, and I have a set of all these tweets that are my negative examples. So now it's up to me to kind of analyze these tweets and see what features do I think are most predictive in terms of defining the characteristics of the types of accounts or the types of tweets that publish this type of bad content, right? So these are all the features that are available on the Twitter platform, and most of them are self-explanatory. The thing that I want to that I thought was interesting and that I wanted to emphasize on before I finish was that the user follower count and the user friends count. So what happened was that there were all these accounts that were posting bad content, right? But the thing was that instead of looking at the raw number of followers and the friends count on Twitter, so the followers are the number of people that follow you, friends are the number of people that you follow. The interesting thing that, this was one of the most predictive features in terms of determining what type of tweets or what type of accounts were sort of the wrongdoers, right? This ratio, so it turns out that most of the accounts that publish this type of content, they have a very high friends count. They ended up following a lot more people than actually the number of followers that they had. So this was one of the more predictive features that we had. Another highly predictive feature was the URL. Most of these tweets are trying to get users to click on a link to lead them to an illicit online pharmacy. So most of them had some type of a URL in them. Things like hashtag was also a very predictive feature. These tweets are trying to get as many audiences and as many sort of views as possible. So they end up using a lot of hashtags. In fact, it's also, like sometimes we also found that they used hashtags that were not relevant to the content. Like if there is, Oscars going on, there used to be, hashtags about Oscars and things like that. And once the features were engineered, it was a matter of building a simple logistic regression, and we were able to achieve fairly high AUC precision F1 scores. I don't have the exact scores up here, but you're welcome to read my paper. I think that's kind of the end of the talk. This is an overall diagram, and thank you.